So it's 10:30. I'm gonna stream until, so I'm gonna do an hour and a half, I think. So I'm gonna stream until midday. I'm gonna keep going with the whole thing. But first, some music. Which, if you're watching the video, you probably won't listen because I removed the audio track for copyright shit. So yeah, fucking where were we? There we were. Okay, so this was rotation, and I think we were doing shifts. Yeah, this is logical, I'm pretty sure. No, left. Shift, arithmetic. Okay, so shift left, arithmetic. And I was just looking at it. So left arithmetic shift is just basically it shifts and it puts a 0 on the other side. And the right one shifts as well. This one gets erased, but the sign bit. So basically a left shift is, as far as I know, the same as a logic shift. Arithmetic left shift is the same as a logic left shift, so there we go. Yeah, I guess. Yeah, because it's just a 0. So left shift is the exact same. Same for arithmetic and logic. It's the right one that changes, which kind of makes me think, like, why is there? It makes me wonder, why is there was there a logic one at all? There's a logic one. Oh, and then there's a swap. Okay, so there's no logic left shift because it's the same as arithmetic. Okay, that makes a lot of sense. That's very nice. Okay, so we were doing SLA. Shift left arithmetic. Very cool. Okay. So what does this do? Well, I'm pretty sure we haven't been setting the flags as we should as well, because I think I took a look at that the other day. Or yesterday, actually, because I streamed yesterday. Oh, also, plan for today is stream until midday and then go do a bit of training, and then probably come back, because I have to do math, sorry, because I just found out that I have these classes that I failed last year that I actually have to do this year. I have to do them. There's no option. You can't opt it out and do second and third year classes instead of those. So I'm really gonna have to start hitting it with the math, but it's kind of hard to do math on stream. And I kind of want to stream, like that's my thing right now. But I don't know. So I might come back with math stuff or might not. I don't know. But there was, okay, there it is. So if it's marked 1, it is set. If it's marked by this, it's not changed, as you can see in the set and the reset and the bit ones. Oh, in the bit ones it's set. Okay. So half carry, I think. What is then? No, the carry flag remains the same. The half carry, and the bit one at least, is the half carry is 1. The yen, which is subtract, is also, no, it's actually 0, and the Z flag is whether or not it's 0. Okay, so course the carry actually is actually set, but the other two have to be zeroed out, which I am not doing, and I should be doing, and the 0 flag should be set in accordance to what is happening. So I'm pretty sure this sets the C flag as well for the bit that's thrown out. This one doesn't because it's, no wait, this is arithmetic as well. So the left shift sets it, but then okay, that's confusing. I guess we should go and hold up. Is this SLA? It is SLA. The fuck is S? I'm guessing S is a Z80 flag that isn't present on the LR. By LR I mean the processor we're working on. So Z is by definition, which means if it's 0 it's set. And actually let me just, yeah, the carry flag, okay. C from bit 7. H and N reset, we know that already. And C from bit 7. Is bit 7 before the operation or after? Because that's a big thing. It should be before, right? That would be the only thing that made sense. That would be the only thing that makes sense, actually. Okay, so I mean, I don't know, man. Actually, we should probably fix some of these. I mean, I guess we'll do it later. I guess. We'll do all of them at the same time, like fix the flags and shit. For now, let's just implement the functionality itself. Okay, I'm getting distracted. I'm sorry. So SLA left shift. So we do, first of all, we gotta figure out what we are doing, which kinda needs this. This is not 24, that's 24 plus 8, which is 32. I'm pretty sure at least. It should make sense, because it should be this one. 16 plus 16 minus 32 goes here, yes. Okay. Okay, so we got that done. And I like listening to the music. It's real cool music, by the way. Fuck. So, left shift. So we do libite. So you gotta set the flag on this one? We do. I'm just not sure if it's before or after. And bit 7 is the one in the end, I am pretty sure. Yeah, bit 7 is the one in the end. So I'm guessing C from bit 7 is before, so we should actually get bit 7, which is last bit, equals libite shifted schwam. Sure, shifted by 7, and then in the end we set the carry flag to it, and then we just shift this by 1, and that should be it. And why not? Let's just keep it consistent. Okay, so I think SLA is done. I'm probably fucking something up real bad, but whatever, we'll just fix it later. Maybe I'm not even fucking anything, I'm just used to doing it, and I think I am doing it, even though I'm not. Yeah, so same thing here. Actually, something the entire thing is the same thing. This is +8, which is 40. SRA. Yes. Oh, Jesus. So last byte is N1. Last bit, actually. And then we shift it to the right. Oh, this is the one that's arithmetic as well, RSA, yeah. So arithmetic right shift. Damn. We should probably check. Oh, so the bit 0 goes into carry flag, and bit 7 remains unchanged? Yes, unchanged. It does make sense because of this. So this one goes into the carry flag, but I think we need another one because this is gotta remain unchanged, so we'll just do last bit too. Left. This is the last bit on the right, and this is the one we want to keep is the last bit on the left. So because we shift the bit on the left, the 7th bit is always going to be 0 anyway, because you know that's how shifts work. So we can just end this by, what is it? You can just end this by 7F, which I don't know how I didn't guess it. So let's do last bit left equals byte and 0x7F, and then yeah, then we shift it, and then we do or equals last bit left. You can just put this here. Yes. Yeah. So that'll do this. And since we already have the last one, all we gotta do is set it to the flag, which we're doing already, so I think this is correct. What is this? Okay. So my PC just blue screen. Fucking out of nowhere. Which is funny. Couldn't you hold up? Can I pin it? Pin to test. That's good. Yeah. Okay. I don't know why that happened, to be honest. Hopefully it saved. I think it did. Yeah, it wouldn't make sense for it not to save. Yeah, everything's here. Well, I guess let me just check the footage for a sec. I'm curious now if this even Where's that? Are you serious? Okay. So one of these is now, which is probably this one. Yeah. This one's probably corrupt. It is corrupt. Okay, fuck. Well, I don't know. I might like just throw this in some editor later. Because it's kind of working, right? The footage is working. You can go forward, but I don't think you can seek. Yeah, there's not even. Oh, okay, there it is. This is RSA. Yeah, RSA. And then it just dies. So this was like minute 9, 10, 10:36. 10:50? 11? Oh, I'm still doing the whole thing. 12:13, 14, 14:17. Okay. 15. So let me see what happens if I even move my cursor. That'll be funny. Come on. Yeah, it just dies. Okay, fine. Let's just keep going. I have 1 hour left. 1 hour 10 minutes on the stream. Hopefully I can edit that. Because I really don't want to lose this footage. Yeah, so SRA is done as well. Hopefully. Yeah, I think it is. So let me just in the chat. So the next one is swap, which I have no idea what it does. Swap. Ah, come on, you're serious? What the fuck does this mean? Oh. Four-bit aggregation. Half an octet. Okay. So swap is just swap middles. Okay, so shift. Yeah, I think I know how I'm gonna do this. There's my little swappy boy. Like this. Okay, so now we don't need this. What we do need though is, hold on. So I'm gonna swap it, right? Which is always the same thing. So 4 bits is 1 hexadecimal. Just a calculator. 1 hexadecimal thing. So, but yeah, it's 1 number per se. Okay, so we got to shift 4 to the left. First of all, we gotta get the bits that are gonna be left out when we shift. So maybe we do, I don't know, left out, I guess, equals libbyte shifted by 4. So that's gonna get us the higher bits. So it's gonna get us the first 4. Anyway, like the first 4 is gonna put him here in this number. Now what you gotta do is libbyte and shifted 4 to the left, which is gonna put the last or the first 4 bits on the left here, and then we're gonna OR it. So OR equals left out. Great. So what does this change? Just changes to 0. Everything else just gets zeroed out, which we will take care of later, along with all the others. Man, this is a lot of fucking shit. Flags are a fucking pain in the ass, dude. Legit. Okay, so what do I do 0x06? Current instruction. Oh shit. Oh shit. I should have done this. And this is wrong. Oh no, it's not. Never mind. This is not wrong. Actually, it is wrong. It is wrong. It should be the current instruction, which is going to be a number. Then we subtract from it. Jesus, that almost was a big mistake. Big mistakes were made. But found before they could actually do any damage. That's a lot of damage. Yeah. Nibble. I did not know about that. I did not know nibble was a word. But yeah, now we gotta do this here as well. Which kinda makes me think that we should have. Jesus. Why not? Well, I mean, because it's a lot of trouble, but. Just do it individually, hard coding it. I don't know if it's the best idea, but. How bad an idea can it be? If it's my idea, haha. I guess then it could be really bad. My ideas are fucking garbage, man, for the most part. Really bad ideas. Which reminds me of that Run song. Fucking Bad Eggs or something. How was it? Well, I guess it doesn't even matter because you can't hear it on stream. On the recording. Okay. Yeah, so this is done, I think. So now it's the right. Oh, it's the logic one. Logic right shift. Man, this is fucking fun, dude. Shift right logical logic. Can I do like the other way around, like logic right shift? LRS would be much better. Would sound right. And this one is 48, 60, 6, no, 50, 56. And then the next will be 64, which makes sense, okay. Is it space 2? And here as well. 56. Why? This type of shit bothers me, man. I gotta start Control Zing when I paste. Maybe there's some setting to not have Visual Studio fucking change your shit automatically. It's really annoying because then you look back at your code and like, I didn't code this shit. This is garbage. But no, it was you. I mean, it's really personal preference, but my personal preference is to have this. Because this is fucking clean, man. And not fucking 1, 2, 3. And I'm very good programmer, my friends. Fucking cancer, dude. I don't know. So this is logic. So this is just a normal shift. But the bit gets set, I think. So we need the last bit thing. This is SRL. A 0 is put into bit 7. Oh, it put into bit 7, okay. And the bits are all shifted right with the bit 0 put into the carry flag. Yes. Okay, so we do the same here, last bit. Since it's a right shift. Since it's a right shift, we do the end one thing, so libbyte, make sure your last bit equals libbyte in 1, and then we just shift it right. Shift it right, and then we set the flag to it, which is very fun, very nice, very fun. I think that's it, and I think we're done with these. This is another row of random shit. Nope, no, it's the bit ones. Now the fun begins. Okay. Ah, nice. It's the bit ones. Yes. Bit, reset, and set. Let's fucking go. So what does this do, actually? Bit. So what does it do? Actually, didn't we have... Yes. Bit. There's just a 0 flag? What is SP? Oh, Z if 0 flag is 0 flag. S equals register, I guess? Rachel. So Oh. Oh, okay. Okay. So it just tests. Yeah, sure, that makes sense. And then it sets the flag. Right? Z. That doesn't actually change anything. It just tests it and sets the 0 flag to the result. It does make sense. Okay. So now okay. Oh my god, so annoying. So current instruction by 8. I mean, fuck. This always fucks me up. It's like you think you know it, but then you actually don't. So these are all the same. So this one will be executed first. Actually, this one will be executed first, and then this one. I think at least. Yeah. It's later precedence after this. And holy shit, this is. Oh, but this only happens in the end of the operation, so it makes sense that it's very early precedence. Okay. So this is current instruction, and what we want to do is get the bit value. The bit value is going to be rest 16. Actually, not rest 16. It's going to be rest. It's going to be minus something rest 16. So bit 0. Okay. So it's going to be minus 16 times 4. Oh shit. It's rest 8 as well, because it's every 8. So this is going to be bit. One shifted by current instruction minus fucking, well, how much is it? 16 times 4. It's gonna be 64. No, it's gonna be 58. Oh, this is hexadecimal. 16 times 4, 64, exactly. So minus 64. Percent 8. So then we gotta figure out and then oh, there's no. Okay. So now we do No, we don't need it. We can just set the flag. We don't need this bullshit. Or do we? Let's just do it first. Okay, so we got the byte. What do we want to do? We want to check if it's okay. So the byte is gonna be equals. So we're gonna do an end. We could actually turn this into one liner. Oh, come on. Isn't finding this other one. Isn't it finding the other ones? Wasn't only finding. Am I stupid right now? It's the exact same. Okay, no, fuck it. Actually, we could do something else. We could do. No, this isn't last bit. This is just a normalized result. Right, it makes sense because this is the current instruction. So this is gonna be the bit, right? We're gonna get this value here. This is a 3, right? Because we're gonna subtract 64 to it. So we're just gonna make it like it's bit 0 is gonna be 0, right? And then we're gonna get the rest of the division by 8, which is gonna give us, if it's less than 8, it's gonna be 0. If it's more than 8, it's gonna be 1. If it's more than 16, it's gonna be 2. If it's more than 16 plus 8, it's gonna be 3, and so on. So that's gonna get us this value. And since we already got the register from, you know, this whole formula, quote unquote, what this is gonna give us, this is gonna give us the exact bit, so the location. It's gonna get us the mask, basically. So if you're gonna get bit 0, it's gonna be, in this case, if it's one of these 8, it's just gonna give us 1, right? It's gonna give us 1 because it's gonna shift it to the left by exactly 0. So if it's not gonna shift at all, if it's one of these, it's gonna shift it by 1. So we're gonna get 2, which is the second bit, and then we're just ending it to check if the bit, so that this is a result, right? So then we're just ending it, our byte, by this bit, and this is gonna give us whether or not this bit is set in this byte, which is cool. and then we're just normalizing it. This is normalizing it. It's just setting it to 1, you know. So if it is in the byte, basically this result is going to be the same as this, as bit. If it's not, it's going to be 0. So not 0 is 1 and not 1 is 0. But if this bit is, for example, bit 3, that's going to give us 8, right? Or 4 actually. It's going to give us 4. So bit 3 is going to be not id, you know? So it's going to be 0, and then it's going to be not id again, and it's going to be 1. So that's basically normalizing, and then we're basically getting 1 or 0, the result, and we're shifting it by 4 and putting it into the flag, into the carry flag. Oh shit, it's the 0 flag, holy shit. Fuck. Okay, well, is the carry flag the last one? Carry flag is the last one. So this, so it's the 0 one that gets set. So this is all wrong. This mask is wrong. So which one is the 0? The 0 one is the fucking last one. So it's 7F, right? Jesus. God damn it. 7F, exactly. So we're gonna end it by 7F to delete the 0 flag. Actually, we could do it by 0 and 1. I mean, I don't know. But anyway, we gotta set this. We gotta shift it by 7, so we can get it in the 0 flag spot. So if we have a 1, we gotta shift it by 7, which will be here, and then we're ORing it, so it's setting it. So this is cool. And I don't want to have this, but I kind of don't want to have this inside of here either. It's just gonna make it way unreadable. You know, this is already not very readable. This is already not very readable, is what I mean. So, I mean, this is readable, but it's a lot of variables. I don't like too many variables. I mean, I know it's gonna get optimized, but So in these, none of the flags are set, which is great, because I don't like setting flags. So now we have the reset flag. Okay. What time is it? 1:15. Alright, yeah, so this is the same, except now we have 16 times 8 instead of just 4. 16 times 8 is 128. Is it? It is. Yeah, it makes sense. So our bit 128. So this is the reset. So all you gotta do is end. Then instead of bit, we're gonna call it mask. And we're gonna knot it. So basically now all we gotta do is libbyte the reference, dereference libbyte, and do end equals mask. See, because this is the same thing, we're just getting the bit, right? We're getting the bit inside our variable, but then we're knotting it. So it's gonna invert all the bits, right? So imagine we want bit 2, fuck, 2. We want bit 2, it's gonna invert everything, right? Bit 2 is gonna be 0 because it gets inverted, and then you're gonna end this by the mask. So everything else is gonna be the exact same it was before, but this bit's gonna be erased, right? So basically we're done here. And now it's pretty much the same exact thing for the set flag. or the set instruction. This fucking, oh shit, this fucking thing, man. Okay, so now set's the same thing, but the opposite. So I think you're gonna have to do it with an OR. Yeah, that's it. So we don't invert it. We keep the bit, but then we OR it. Oh, we OR it by the mask. And if I'm not mistaken, this is correct, and this is the bit, not the mask. Because 1 or 0 is 1, and everything else is 0, so it'll stay the same. So yeah, that makes sense. So that's the bit instructions done. We should actually look into the flags a little bit more, because yeah, we should go fix the flags now. I've been postponing this for way too long. So RLC, Jesus. God damn it, dude. This is way more trouble than it's worth. So first we're gonna zero all these out, right? This is RLC? Yes, it is. So we're gonna zero all the flags out because these two are 0 and these are gonna depend on our result. So yeah. Whoa, no. Zero F. Okay. Actually, let's just copy the whole thing, and instead of last bit, we're gonna do. Look at this. Look at this. And instead of last bit, we just do le byte. We normalize it. Oh, what's up? What's up with this? Ding. Oh. And we push it by 7, which I think is correct. This would be so much faster with This would be so much faster with fuck, what am I trying to say? If we just translated it to x86, because x86 already has the flag and everything, so I mean, I don't know. This is basically like predecessing architecture. Z80, so it was like 8080 and then was Z80. I don't know what was after. Where is it? 8080? No 8080? 8088. Damn, I think this. What about the Z80? Are these just like game processors? Oh, these are the processors, not the architectures themselves. Is that a Note 8080? Anyway, Jesus. List of instruction sets. 8080, please. 8080. 808021. Yeah, 8080. Oh, so these are already x86. Where's the Z80? So I guess the Z80 has nothing to do with the 8080. Because that other one is Intel. Yeah, so this is Intel. So they just kind of mixed the Intel. Well, I guess they didn't mix it. It's just that has nothing to do. I don't know why. Hold up. Alright, where? Why is it similar to an Intel 8080? Introduced in the Z80. But like, I don't know, I guess like maybe because the registers have the same names. I don't think I care that much to figure that out, but yeah. So, what do we do? So we fixed this one. And now we get to fix RRC, which is the same thing, gladly. So this is 0F. And then we just do this after. This is 0 flag. Damn! This is fucking nice, man. It's just fucking copy pasting. Yes, so good. I don't know, maybe I should make like a macro for this. But then, you know, but then it would change because reasons. Then it's like, eh. I could make a function though. Instead of just fucking copy pasting this everywhere. I could make a function to set the bits of the flag. But then there'd be a problem that it would set the bits unnecessarily. You know? I don't know. Maybe I'll do it, maybe I won't. I don't know if it's necessarily worth it. Where's the RR? RR, same thing. SLA, same thing. SRA, same thing, I guess. No, it's not. So the only thing that matters is 0 flag. SRA. Whoa, hello. What am I doing here? So SLA, I'm setting it. Why am I doing this? Why was I putting it in the carry flag? SRA. What was I putting in the carry flag? That's the question. So I guess last bit really isn't used, is it? Hold up. This doesn't make sense. Is this SRA? It is. So shift right. Why am I doing this? Am I stupid? Oh no, because yeah, you're shifting to the right. I'm fucking stupid. Yes, and then you're R-ing it because the last bit in the first thing. Yeah. Okay. Yes, that makes sense. The swap one is the 0 as well. Just the 0. Yeah. SRL has the C one. Eh. So 0, 0. And then the bit one is more complicated. Okay. So it's 1F. The bit one is. Oh, so this doesn't change. And this has to be 1. Down. But then I guess I could 0 it. I should 0 it. Or should I? I don't have to. I could just OR it by 1. By a mask. Yeah, in the one place I shouldn't do this. Okay, So now we gotta set that to 1. And the 1 is a third. Okay. And these other ones don't change at all, so not even worth switching. Yeah. Okay, well I could try it now. But I guess the compiler is gonna scream at me for not having any of these functions. And I kinda don't want to implement them right now. So what I could do is I could in each of these just print out the thing. Right? Could do printf or puts and then do the name of the function or the instruction. Oh, there. Okay. RLC. Ah, fuck. RL. Man, I don't want to do this because then I'm gonna have to erase it. So maybe. Oh, come on. This is SLA. This is SRA. Just swap. SRL. Bit. Reset. And set. And then. Okay. What am I doing? Put CB prefix. Okay, I guess now we have all of this. So I could just do it in memory. I don't think I need any of this. So we include And now we do lr our CPU dot memory equals, how much is 8? So 1024 times 8. 1024 times 8. It doesn't look right, but you know. And then what? Then we do PC. Should run instruction be relative to PC? And like not have this parameter at all? We can make a wrapper. So we do run instruction like this, and then we would do a wrapper. This was a mistake. I should have put like some kind of placeholder. So yeah, so we do this, we do and then we memcopy into our CPU dot memory. And what we want to do one instruction. We want to do RLCB. So we do CB CB fucking 00, and I guess that's it. But this rotates B1, so we do our CPU dot registers dot array dot B equals so we're rotating left, so why not just do like this? This should 0x81. This rotated should be like this, right? Yes, should be 3. Rotated should be 3. Okay, so then we printf B, and then we do the result, and then we do 0, and then we do carry. Our CPU dot registers dot array dot B, and then we do dot F shifted by, and this is 0, so this is shifted by 7, and actually this is shifted by 7. And then we do dot f shifted by how much? This is 4, supposedly, to get the carry flag. 1, 2, 3, 4, yeah. By 4 and 1. So I think this is gonna crash, or not compile actually, I'm just compiling now. Yeah. Uh-oh. Int to void. What? What can you not convert? Damn, where? Hmm. Okay, I think we should go back to the... This is gonna be a hell of a problem. Guess you could make a macro. LR function, I guess. Jesus, this is gonna be hell of a macro fucking C. I guess, and LR, whatever. Like this. Okay, well. What the fuck is this thing doing? Oh, there we go. It's gonna have to do this 200 times. 256, actually 500 times. But I want to replace them all because, you know, these ones. Well, actually what I could do is... Yeah, that's much better. Yeah, it's not gone anywhere else, so... Oh, but these already... Okay, hold up. Oh, and these don't get replaced. Damn. Anyway, that's better than nothing. Boom, 480. 480. And it doesn't fucking do jack shit. Such a pain in the ass, man. Holy shit, like, look at this. So ugly. Fuck. Oh well. Oh, never mind. Expected an identifier. Oh, that does make sense. Fuck. So... I guess none of these... Oh, please just compile. If you don't, just... At least... Yes. Tommy doesn't get on the... Okay, that's good. What is this DL? Oh, it's DL. It's DI, actually. Oh, but I can just comment these out. I mean, I guess I eventually would have to create definitions for them, so why not? Oh, it's creating before. Well, that doesn't really matter, I guess. I'm sorry I have to do this on fucking stream, it's boring. Fuck, you know. There's gonna be so many. Such a pain in the ace. Hold up. Oh, these are... Well, there's gotta be a simpler way to do this, like do all of them. Oh! No, it doesn't. Please. Fasten your seatbelts. Almost there. 3 more. 2 more. 1 more. Done. Okay. Jesus. Please compile. Oh shit! Let's go! Please don't crash! Okay, well. Well... it didn't even... Uh-oh. Oh, I didn't execute anything. I'm fucking stupid, man. I should make these private. All of the yeah, I guess that's cool. Boom, crash. Oh! Shit. 0 is not 1, though. 0 flag is 0. CB prefix RLC. Hopefully. Oh, yeah. Okay, cool. But, so the carry flag should be 1. If we do, instead of 81, just 1, the carry flag should be 0. It is. Nice. And if the whole thing is 0, I think the 0 flag is just upside down. Yeah. Okay, so I managed to do the fucking 0 flag wrong. Not. So if it's true, if it's a number, the 0 flag is gonna be 1. So it's just not. Okay. I'm pretty sure I didn't use this anywhere else. So. Yes. Yes. Feels good, man. Holy fuck. There's 10 minutes left to this stream. I've been successful. And this fucking music is so adequate. Damn. I would advise listening to this if you're watching the recording, just for a second, because it fucking feels good right now. Ah, oh, Jesus! Oh, fuck. Sorry for that. My mic kind of fell off the desk. So what else? Oh, you could do the HL ones, actually. So the HL. Oh shit. Well, I might have to edit that out. That's for sure. Fuck. Hopefully that one viewer is me. Yeah, so what do I click shit randomly when I'm thinking? That's the real question. Fuck. So I want to do CB, and actually I should check the PC as well. I should do this hexadecimal actually. This should be 2. 12! Ooh. Ooh. Oh damn. Starts as 0 and it ends in fucking 20 something. Not 20 necessarily. I think, yes, no, it's like actually 20 or 19 or something. How much is 12? 18, yeah. Uh-oh. That's not good. Let's just fix this real quick. Added 1. So why is this 12? Jesus. Actually, hold up. Jesus, why? This only gets executed once. Why is this 18? Am I... This is ridiculous. Ridiculous. One. This is still 1. This is 2, but this is 18. And I do not understand why this is 18. Though... It's probably still, yeah, still inside the union. I figured. There we go. Please see is 0, 2. Which is nice. So now we do 4. Like we do 5, and we do CB, what's one with HL. So we're gonna get bit 1 from HL. So we're gonna do, which one is this? This is E, 3E. 3E. Dot HL equals 0x. So this is 0, 1, 2, 3, 4. And then we do 0x, 1, 2, 3, 4, 5. Yeah, exactly. And then we do, so the HL, the reference is gonna be 2. 0x, 0, 2. Oh, 0x, x, 0, 2. Exactly. So then we rotate B. No, we don't want B. We want memory. And instead of V, we just do CPU dot memory. And because it's because it's a char, we just do 1, 2, 3, 4. 0, 1, 2, 3, 4. We're not actually rotating, so we're just checking the 0 flag. Yeah, 0 flag, you want to know if it's 0 or not. So we're not actually doing anything, but... Oh, 0 is 0. I think we might have something to do... Oh, 0 is 0, so it means there's something there. If it were 1, 0 flag should be 1. Oh! Feels so good, man. And the carry flag is 1y. Carry flag should not be 1. Is it set to 0? It is. Carry flag should not be anything, really. Should be the same in both instances. One F. So I guess I'm just not changing it, but it still should be the same. Hold up, let me just set like a fixed value for it. Damn, that doesn't make a lot of sense. So like, if I do our CPU dot registers dot F equals 0 and run it. If it's due, the 0 flag should be 0, of course. So if the specified bit is not set, 0 is set, 0 is 0. It is nothing. Right, what if we do 1? Why is the carry flag 1? Like, the 0 flag makes sense, but the carry flag does not. And this also doesn't make sense. This should not be 0, this should be 0, 1. 0, 1, 2, 3, 4. What is 62? 3E. Okay, so it's time for me to go though. Fuck. It should not be 0. Oh, it's wrong. It's saying it's SRL. Why is it saying it's SRL? Well, consider me confused. It ends at 04. What is SRL? No, but it makes no sense. It should be 3E. Which... No, it's not 3E. Wait, it is. It is 3E. So why is it... 3. It's not 3E, it's 4E. 4E. That makes more sense. Jesus, I'm stupid. It's 4E. God. So now it's 1. Now the 0 flag is 1 and the carry flag is 0. And if it's 2, the carry flag should still be 0, but the 0 flag should be 1. Whoa, hold up. If it's 2, 0 flag should be 0. Right? It's bit 1. It's bit. Let's just do 0. 1, sure. Let's do FF. Oh, now it's 0. Okay. So, I fucked up somewhere. Zero flag is 1. 0 flag is still 1. 4. What the fuck? Damn. So if I do FF, it's going to be 0, right? Yes. So if I do F0, okay, so why is it getting this bit? That makes little sense. I should be going, fuck. Yeah, this is some nice music, man. Holy shit. This one goes in my playlist, that's for sure. So yeah. Getting bit 6. Why is that? Why is this 14? 6, 7, 8, 9, 10, 11, 12. Oh, actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, it is 14. Which rest 0, rest 8 should be 2. Or am I completely fucking mistaken? 14, rest 8. Hold up. Mod. So 14 mod 8. Oh, it's just division. What am I doing? So, okay, this should work. Nice. Okay, so it's working now. That's cool. I don't think I'm gonna be doing much else. Just make this a little bit decenter to end this in a nice note. Do 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 do. Carry is 1. B is 3. Carry is 1, which makes sense. Z is 0 because it's not 0. God damn it again. Oh, 0 is 0 because it's 1. Okay, yeah, that makes sense. That's cool. That's coolio. So yeah, bitwise ones I think are done. Probably some mistakes in there somewhere, but whatever. Whatever. So yeah. This stream, I'll see you guys maybe this afternoon, maybe, I don't know. Maybe tomorrow. Who knows?